Yabba dabba do. Welcome to lesson 4-2, folks, boys and girls. Our lessons on operations with polynomial functions. So, if I want to add two polynomial functions, basically all I'm doing here is I'm combining like terms. So I'm going to add this polynomial with degree of 2 with this polynomial with degree of 2. So all we're going to do is we're going to combine like terms. Let's just, well, mark those. I know you guys noticed, but I'm going to match up my x squareds. I'm going to match up my x's. And I'm going to match up my number terms where I have an x to the 0. So when I do that now, we'll write our answer in black. Okay, negative 5x squared plus negative 8x squared is negative 13x squared. Plus 4x plus 2x is plus 6x. And negative 2 plus 1 is negative 1. Bump, bump, bump. There we go. Negative 13x squared plus 6x minus 1. Alright, in order to subtract polynomial functions, you just got to make sure we distribute our negative through the second function, dist our neg, so change each of those signs in that second function. But we're going to do the exact same thing. We are going to combine like terms, so this is going to be negative 2x to the fourth minus 3x to the third plus x squared. I'm just distributing my negative through to each term now, right? Minus x, whoop, just dist that neg, plus 4. So let's combine like terms. Here are my x to the fourths. 7x to the fourth minus 2x to the fourth is 5x to the fourth, minus 9x to the third minus 3x to the third is minus 12x to the third, minus 4x squared plus x squared minus 3x squared, plus 5x minus 1x is plus 4x, and plus 6 plus 4 plus 6 plus 4, I said plus 6, plus 6 plus 4 is plus 10. Alright. Okay, to multiply polynomial functions, we're just going to FOIL, or sometimes we got to do more than that. If I multiply two binomials, of course I FOIL. In this case, I'm going to multiply a two-termed expression, a binomial times a trinomial, but it's the same thing that you're going to do. Just like when you FOIL, you're going to have to multiply each term in the first polynomial to each term in the second. So I'm going to do negative x times 2x squared, which is negative 2x to the third. Negative x times 5x is minus 5x squared, and negative x times positive 8 is negative 8x. Now I'm going to do the negative 3 to each term, so negative 3 times 2x squared is negative 6x squared, and I'm going to write that below here so I line up my like terms. Negative 6x squared minus 3 times positive 5x is minus 15x. And negative 3 times positive 8 is negatory 24. I'm going to combine my like terms now, so we'll do that in green. Negative 2x to the third minus 5 minus 6 is minus 11x squared. Minus 8 minus 15 is minus 23x minus 24. There I am. Okay, I'm going to multiply a trinomial times a trinomial. Same idea here. We're going to multiply the 3x squared to each of these terms. So we're going to multiply, let me get a marker here. We're going to multiply the 3x squared to each of those terms. We're going to multiply the x to each of those terms. And lastly, of course, we're going to multiply the negative 2 to each of those terms. We'll go up top here in yellow. Okay, I'll be right back. I'm going to let you do that multiplication, line up your like terms, and add up your terms. Okay, when you multiply the 3x squared times each of these terms, we get this right here in green, neg 12x to the fourth minus 6x to the third minus 3x squared. The x times each of these terms, we get neg 4x squared minus 2x, negative 4x to the third minus 2x squared minus x. And when I multiply the negative 2 times each of these terms, positive 8x squared plus 4x plus 2. When I add up my like terms, the negative 12x to the fourth is right here, neg 6, neg 4, neg 10x to the third, negative 3x squared minus 2x squared plus 8x squared is positive 3x squared. This gives me positive 3x plus 2 at the end. Here is my final answer. It's a fourth power polynomial function. Okay, if I have to multiply three polynomials, so in this case there are three binomials, I just need to multiply the first two, or any two, first. Multiply 2 first, get that answer, and then multiply it by the remaining polynomial. So in this case, I'm just going to foil. I'm going to foil the x minus 5 times x plus 2, so I have x squared plus 2x minus 5x minus 10. When I combine like terms, I get x squared minus 3x minus 10. I'm then going to take that and I'm going to multiply by x minus 6. I'm going to let you guys finish this problem, and I shall be right back. Okay, you should have gotten a final answer of x to the third minus 9x squared plus 8x plus 60. I multiplied the x squared times each of these terms, x to the third minus 6x squared. Negative 3x times each of these terms gave me neg 3x squared plus 18x, and then negative 10 times each of these terms gave me neg 10x plus 60. Notice I was lining up my like terms, and we just added them up to end up with our final answer, which is a third power polynomial function. Okay, the binomial theorem is a shortcut that we can use to expand binomials, and what I mean by that is if I raise a binomial to a certain power, okay, n is the degree of the binomial. We'll talk about the r in class. Okay, we'll talk about the r in class, but you're going to get an expansion that looks something like this with a bunch of terms depending upon what our power was. We're going to use something called Pascal's triangle, and I want you to complete this in your notes. Pascal's triangle starts with a 1, and then we're going to make a series of 1s going down on either side. As you can see, we're going to make a triangular shape. Okay, and Pascal's triangle is used to get the coefficients of our binomial expansion. So we start here. This is the what we call the 0th row, and you'll see why in a moment, because this is our first row where I have a 1 and a 1. And now to get my middle terms, what I do is I take the 2 here, and if I look up above on either side, I have a 1. So these two 1s add up to a 2. This 1 and the 2, they add up to a 3, so this gives me my 3 right here. The 2 and the 1 give me a 3 right here. Okay, now this next row, this is what we call the 4th row. So this is the 0th row, the 1st row, the 2nd row, the 3rd row, the 4th row. Notice that our row is always one less, our 4th row. This 4 comes from 1 plus 3. This 6 comes from 3 plus 3. This 4 comes from 1 plus 3. Of course, we end with a 1. The 5th row, I got a 5, 1 plus 4, a 10, 4 plus 6, a 10, 6 plus 4, a 5, 4 plus 1, and I end with a 1. You guys go ahead now and complete this next row. Again, we're going to start with a 1, and we're going to end with a 1. Fill in the middle coefficients. Okay, you should have had 1, and then 6, 1 plus 5, 15, 5 plus 10, 20, 10 plus 10, 15, 10 plus 5, 6, 5 plus 1, and 1. Notice in Pascal's triangle, the first half of the terms are repeated in the second half. So I have 1, 5, 10, 10, 5, 1. 1, 6, 15, I have a lone 20, but then I end with a 15, 6, 1. If you wanted to do a 4th row, you could. Or I'm sorry, a 4th row. A next row, we're going to start with a, we'll do it in purple, a 1, 7, 21, 35, 35, 21, 7, and 1. And I'm getting those by adding my consecutive terms right above. Okay, so to expand x plus 1 to the 6th power, I'm going to look back at my Pascal's triangle and go to the 6th row, which I know was 1, 6, 15, 20, 15, 6, 1. Notice that the number of terms I'm going to have in the 6th power expansion is going to be 7 terms. It's always one more than the n. Okay, so I have 7 terms right here. 1, 2, 3, 4, 5, 6, 7. And those are going to be my coefficients of my binomial expansion. So what I'm going to do here is I'm going to write down here, I have 1 times x to the 6th power times 1 to the 0 power, plus my next term is going to be 6 times x to the 5th power. Notice I'm going to subtract 1 from each of the x's times 1 to the 1st, plus my next term is going to be 15 times x to the 4th power. I'm going down in my x's and up with my 1's. And I guess the 1's really don't matter that much, but it's 1 squared plus 20, need more room here, 20 x to the 3rd now, 6, 5, 4, 3, 1 to the 3rd, plus 15, go down from x to the 3rd, go down one more, x squared, 1 to the 4th power, plus 6 times x to the 1st, 1 to the 5th, times 1 times x to the 0, 1 to the 6th. Notice, when I expand this out, my exponents will always add up to 6. 6 plus 0 is 6, 5 plus 1 is 6, 4 plus 2 is 6, 3 plus 3 is 6, 2 plus 4, 5 plus 1, or 1 plus 5, and 0 plus 6. Notice my x's, the exponent goes down each time, and my 1's, the exponent goes up each time. So I go from 6, 5, 4, 3, 2, 1, 0, and 0, 1, 2, 3, 4, 5, 6. So now we just need to simplify each of these, and this is pretty easy because 1 is just 1. So I'm just going to write this out now as I have 1 times x to the 6th times 1 to the 0, which is just 1x to the 6th, plus 6 times x to the 5th times 1, 6x to the 5th, plus 15, x to the 4th times 1 squared is just x to the 4th, plus 20 times x to the 3rd times 1 to the 3rd is just 1, plus 15, x squared times 1, plus 6x, plus 1. And there is my expanded binomial x plus 1 to the 6th. Notice I have 7 terms, one more than 6 right there. Alright folks, I think that's plenty for tonight. We shall see you soon. Have a great night.